Hi, I'm class 1, Capital Primary 6. Right now here, we are at theoretical mechanics. Well, for this part of theoretical mechanics, we're at chapter 1, kinematics. Now, in this part of kinematics, we're going to revise some of those things that we might need to keep on using. Okay, so let's start with this. So the first thing I'm going to revise for this time will be about the distance. Now distance, you can describe it as the total path traveled, or the length of the path traveled. Now in this part of distance, you can give different types of shapes. Like for example, this rectangle. Then they'll give you points A, B, C, and D. So they might give you these different points. Okay, then after that they'll give you the different measurements. Like for example, this is 5 meters and this is 3 meters. Then they ask D for a distance might be from A to B. When this is from A to B, it is this part, so it is 5 meters. Then the distance maybe of B and C, B to C, then you get 3 meters. Then if it is the distance of A to B to C to D, then this part will be 13 meters. Now just one whole round for this side. Because A, B, C, D, then back to A. So this part is 16 meters. One whole round. Okay, how about another example here? So let's just say we have this semicircle. For this semicircle, you have the center as O, and there's this A, there is this B. Then they give this radius as 1 meters. After that, this can start from here, then you get a C. Okay, so they can give you these different points. Then they ask for the, so they have given for OB, like OA, well that's just another of this radius, so it is just 1 meters. Or they might ask for ACB. So that means ACB, it goes around this whole, well the outside of this semicircle. So for this part, this distance, well, 2 pi r, then you have to divide it by 2, which is just pi r. And this r is only 1. So this is just pi. But beware, it is still meters. Then how about one whole round again? Like they can start from just O to A, then C, B, O. They can go this way or even the other way. So for this path, there will be 2, then here will be the pi. So 2 at pi meters. So we have this part. This is for our distance. In the second point, for this, it will be the position vector. Now for this position vector, we have that xy plane. Okay, then here is the origin. So a position vector, they will start from this origin. Then it reaches out as this vector. Then you can say it stops at a point P. It stops at that point, so it just goes from O to P with this small something like arrow at the top. So this part is the position vector. Now position vector, this part, it is made up of. So when you put this down, in this x, let's just say it traveled x. In this I vector, well, this I vector is this x component. So it goes this much in the x component. Then since it also went up this much, well, we can use that as y. Then for y, it will be a j vector. This j vector is just for its y component, but both of these, they are both unit vectors. Okay. So for this part, it can be for the position vector. Then in this third part, okay, you have distance, you have position vector. So I'm going to say about displacement vector. For this displacement vector, from here, still this xy plane. Let's just say we have this first vector here. You can write it as R1, then this vector. You say it as this initial position vector. Then it might go up, it might go down. Then you have another vector here. They call it R2, then vector. So this can be your ending position vector. So to go this part, there will be another vector here. Then this part is a delta R vector. And this part for delta R vector, it is the displacement vector. Okay, so this part is a displacement vector. Now we could try out some of these examples. So, for example, let me just draw one of these here. In this xy plane, here is the origin. So from this part, they might give rectangles. Okay, so from this part, here's O. So you can rename these as A, B, C. These different parts. So they might give this A, B. You can give this unit 5 meters and this part below as 12 meters. Then at this part, they can ask from O to A. This OA vector. In this OA vector, so it goes 12. So this part will be 12. Then this unit vector. But wait, how about this unit? So you add this unit in front of this unit vector. Then after that, from O, or even from A to B. From A to B, this part. So it just goes up 5. So you get 5 meters in the unit vector for Y. So it is this shape. So you can write it as these ways. Well, later I'll show another way of writing all of these. Well, so OA, then O, then AB. Oh wait, let me just draw this out. OA will be from here to here. Then AB will be from A to B. Then after that, from O to B, this part, so it goes 12, then goes up 5. 12 meters, I, okay, or this unit vector, then 5 meters here. Okay, so that goes from this part all the way here. Okay, well, I said I'll show you another way of writing this. 12 meters I. Another way of writing this can be 12 meters 0. Now this part would be 0, 5 meters. Therefore, all of these 12. Okay, let me just write this below. 12 meters, 5 meters. Wait, then how about it goes back? Like it can go from O, then to A, to B. How about then back to O? What if it goes like this? So it goes O, A, B, O. Wait, that just goes back to this original. So for this you get 0, or you're just 0, 0. Okay, so you can write it as this. But wait, so that means for these different parts, distance, even when it goes back to the starting, all is counted. But for this displacements, when they go back to starting, it is just counted as 0. So from these parts, these 3 points, that's all that I'm going to revise for this time. Okay, so in this video so far, I hope that you can understand it. So we'll see you in the next lesson. And if you like our videos, don't forget to subscribe to our channel. Thank you for your watch.